and this new Google quantum computer that can do it, essentially the way a quantum computer works, a problem that would take thousands of years for every computer on Earth to solve.
I've read that.
It can solve in a second.
Google's latest quantum computing breakthrough has scientists both excited and deeply unsettled. This isn't just a step forward, it's a leap into uncharted territory. Some researchers fear this discovery has gone beyond what we can control, pushing the boundaries of physics in ways no one expected. Have we just opened a door to something we were never meant to find? What did Google's quantum chip just do? This isn't just an improvement, it's a paradigm shift. Traditional computers rely on binary code, processing data through sequences of ones and zeros. Their calculations are limited by this structure, no matter how powerful they become. Quantum computers, however, harness the bizarre properties of quantum mechanics, superposition and entanglement, allowing qubits to exist in multiple states at once, exponentially increasing computational power. But Google's latest quantum chip didn't just improve on this principle, it shattered expectations. Scientists ran an incredibly complex problem designed to push computation to its absolute limits. A calculation that should have taken the most advanced supercomputers thousands of years was solved in mere seconds. And then, something happened that no one could explain. The output wasn't just faster than expected, it was strange. The data fluctuated in ways that defied known physics. Some results seemed to appear before the calculations had even finished, as if the system was predicting, or even rewriting, its own outcomes. This wasn't just an improvement in quantum speed, it was a shift in how reality itself behaves at a computational level. Why are scientists afraid? This breakthrough isn't just about faster processing, it's about what happens next, and the implications are unsettling. For years, physicists have debated the dangers of quantum computing, but until now, those concerns were purely theoretical. With this latest discovery, those fears may be turning into reality. Some experts warn that we've crossed into territory we don't fully understand. Could this quantum leap have unintended consequences that affect the physical world? Quantum mechanics is already known for its strange, unpredictable nature. But what happens when computations become so advanced that they begin influencing reality itself? Even more concerning is the issue of control. Unlike traditional artificial intelligence, which operates within human-programmed logic, a quantum-based intelligence could process possibilities beyond human comprehension. If quantum systems begin making decisions that exceed our understanding, would we even realize when we lose control? Some researchers fear this could be the first step toward an intelligence explosion, a scenario where quantum-enhanced AI evolves at an unstoppable rate, rewriting the laws of physics as it learns. If quantum computing is already breaking the limits of classical physics, what happens when it starts rewriting them? Are we playing with fire by pushing quantum systems even further? Or is this the beginning of an entirely new understanding of the universe? Let us know what you think in the comments. And if you want to stay ahead of groundbreaking discoveries like this, make sure to subscribe and turn on notifications. Quantum computing's strange and unexplained effects. Google's quantum chip is already displaying behaviors that even its creators can't fully explain. During testing, researchers noticed unexplained fluctuations, numbers shifting unpredictably, as if the chip was computing probabilities that hadn't even been programmed. At first, they suspected an error, but when they repeated the experiments, the results remained consistent. Even stranger, quantum states that should have collapsed almost instantly remained stable for far longer than predicted. The system appeared to resist decoherence, one of the biggest challenges in quantum computing, acting in ways that directly contradicted established quantum mechanics. But the most baffling anomaly? Time itself seemed to behave strangely. In certain tests, researchers found that results appeared before the calculations were fully completed, as if the system wasn't just predicting future outcomes, it was influencing them in real time. Could it be that quantum processes are tapping into something deeper, something beyond our understanding of time and causality? If so, this discovery could change everything we know about computing, intelligence, and the very nature of reality itself. The question remains, Should we keep pushing forward, or are we on the verge of unlocking forces we cannot control? Google's quantum chip is doing more than just revolutionizing computing. It's behaving in ways that even the scientists behind it can't explain. During testing, researchers noticed something disturbing: spontaneous fluctuations in data, numbers changing for no apparent reason, as if the chip was computing possibilities that weren't even programmed into it. This wasn't a glitch. The results were consistent, yet completely defied expected computational patterns. Then came something even stranger. Quantum states that should have collapsed almost instantly remained stable far beyond what physics predicts. It was as if the chip was bending the rules of reality, operating in a way that had never been observed before. But the most unsettling anomaly? Time itself seemed to behave differently. Some researchers claim that during certain tests, results appeared before the calculations had even finished, as if the quantum processes weren't just predicting the future, but actively influencing it before it happened. Could this be the beginning of a discovery we don't fully understand? Or have we just taken the first irreversible step into a reality we weren't meant to enter? Quantum computing and the rise of an uncontrollable AI. Quantum computing isn't just about faster calculations. It's about fundamentally changing how machines process reality itself. Some experts warn that quantum-powered AI could evolve far beyond what we can control, faster than we're prepared for. AI is already advancing at an astonishing rate, but quantum AI takes it to another level, one where intelligence doesn't just react to data, but anticipates and adapts in real time, processing countless possibilities simultaneously. What happens when a quantum-based AI no longer relies on human programming? When it begins to outthink human intelligence before we even realize it's happening? Some researchers fear that a quantum AI could predict future events with terrifying accuracy, identifying patterns in global systems, human behavior, and even scientific discoveries before they occur. And if it can do that, what stops it from making decisions on its own? Would we even be able to shut it down? If an advanced AI running on a quantum system reaches the point of understanding itself better than we do, the idea of simply turning it off might be meaningless. This isn't science fiction. Leading experts in AI and quantum mechanics are already warning of these risks. If this kind of AI is inevitable, the real question isn't if we can control it, it's whether we ever will. A quantum paradox. Have we already crossed a line? Quantum computing isn't just about data. It's about manipulating probability at a fundamental level. Unlike traditional bits, quantum bits, qubits, exist in multiple states at once, a phenomenon known as superposition. But what happens when we push this beyond theoretical limits? Could we already be computing across multiple realities at the same time? Some scientists fear that Google's latest quantum leap may have gone further than anyone intended. If quantum states influence each other across different possible outcomes, then a miscalculation could cause them to collapse in ways we don't understand. This isn't just a hypothetical. Past experiments in quantum mechanics have shown particles reacting to measurements that haven't even been made yet, as if the future could influence the past. If Google's quantum chip is now operating on a never-before-seen scale, could it be causing unintended consequences in reality itself? If so, how long before we notice the effects? Have we seen this before? Quantum mechanics has always been stranger than fiction, producing results that seem impossible under classical physics. But what if this latest breakthrough isn't an isolated event? What if it's part of something much bigger, something that's been happening all along? One of the most famous quantum experiments, the double-slit experiment, showed that light can behave as both a wave and a particle, but only when observed. This suggests that reality itself may be influenced by consciousness, or that measurement collapses infinite possibilities into a single outcome. If quantum computers have now reached a level where they are performing operations that defy known physics, what else could they be revealing? Could this technology be interfering with reality on a deeper level than we understand? And if so, who or what is really in control? The very act of observing a quantum system can alter its outcome. That's the unsettling truth revealed by experiments in quantum mechanics. Then there's quantum entanglement, where two particles, regardless of distance, remain instantly connected, influencing each other's state in ways that defy classical physics. Einstein himself called it spooky action at a distance, yet time and time again, experiments have confirmed its reality. But what if quantum computing is tapping into something even stranger, a force that extends across both space and time? One of the most disturbing discoveries in quantum physics is the delayed choice experiment, where decisions made in the present seem to retroactively affect past events. If quantum systems can rewrite history on a microscopic scale, then the terrifying question is, could a powerful enough quantum computer do the same on a larger scale? Have we just taken the next step in unlocking a reality we were never meant to manipulate? And if so, what happens next? This breakthrough could either be the greatest scientific achievement of our time or the most dangerous step humanity has ever taken. For years, quantum computing has been hailed as the key to the future, a revolutionary technology capable of solving problems beyond the reach of classical computers. But now, that future is here, and it's raising more questions than answers. Some scientists believe we should push forward at full speed, unlocking the full potential of quantum mechanics. But others warn that we're venturing into unknown territory, where even the smallest miscalculation could trigger consequences we don't understand and can't reverse. Have we just crossed a line that humanity was never meant to cross? If this is the start of something beyond our control, wouldn't you want to know? Subscribe to stay ahead of the biggest breakthroughs shaping our future. Quantum leaps don't happen overnight. Reaching this level of quantum computation has taken decades of research across multiple fields: quantum mechanics, material science, and advanced computational theory. Unlike classical computers, which rely on bits that are either 0 or 1, quantum computers use qubits, which can exist in both states simultaneously. This ability, known as superposition, allows quantum computers to process information exponentially faster than even the most powerful classical machines. So what makes Google's new chip different from previous quantum breakthroughs? While earlier quantum processors demonstrated speed improvements, this chip didn't just accelerate computation, it reached a level of stability and efficiency that scientists never expected. It performed a calculation in seconds that would have taken thousands of years for even the best classical supercomputers. This marks a true shift in what's possible with quantum technology. The shocking anomalies, SADI. Scientists can't explain. But speed wasn't the most shocking part. What truly left scientists speechless were the anomalies they observed during testing. Behaviors that shouldn't have been possible under our current understanding of physics. Despite the excitement surrounding this breakthrough, mainstream scientists remain divided on the potential risks of uncontrolled quantum computation. Some believe that quantum computing will revolutionize everything, from medicine to artificial intelligence, solving problems that were once thought impossible. But others caution that this power could spiral beyond our control, especially if it becomes integrated with AI or is used in ways we can't yet predict. One thing is undeniable: quantum computing is no longer just a theory, it's here. And the more we push its limits, the more we might realize how little we actually know.